Hey, welcome back. It's chemistry time again. Hey, today we're going to talk about the combined gas law. What we're going to do is we're going to combine Boyle's law, Charles' law, and Gay-Lussac's law all into one big equation. It's less complicated than it sounds. So we have Boyle's, Gay-Lussac's, and Charles, right? It's all set up the same exact way. So we can put all six variables together just like this, and the problems are easy peasy. We've got to follow all the same rules we did before. Temperature has to be in kelvins. Volume and pressure, the units don't matter, but they have to be consistent. We have to use atmospheres, milliliters, milliliters, torr, whatever. We have to have the same unit for both 1 and 2. Besides that, it's pretty straightforward. So I'm just going to plug myself out of here and pop through this one equation real quick, and that'll be my notes. There's also a worksheet attached. I'll have the answers. I just did them a little bit ago, so I'll have that attached also. All right, let's just go to it. Okay, a gas that has volume of 28 liters and a temperature of 45 degrees Celsius and an unknown pressure has its volume increased to 34 liters and a temperature decreased to 35 degrees Celsius. If I measure the pressure after the change to be 2 atmospheres, what is the original pressure of the gas? So what we're saying, where's my Apple Pencil? That's not what we're saying, but here it is. Okay, so what we have to do is let's get our things all lined up here. Let's get our ducks in a row, as we can say, right? So it has a volume of 28. Now, I don't care if you call this V1 or V2. It doesn't really matter. I'm going to put this as V1 just because it's listed first, right? So 28 liters, and the temperature is 45 degrees. Oops. Wrong line. And the temperature is 45 degrees, okay? If I measured the pressure after the change to be 2 atmospheres, what is the original pressure of the gas? So this is what I don't know. Okay, and then let's go do the other part. It says we increase the volume to 34 liters. Its temperature decreased to 35 degrees Celsius. If I measure the pressure after the change, so that's our 2 atmospheres right here, what will be the original pressure? Now our answer is going to be in atmospheres because our other, I did that again. Okay, hold off, boy oh boy. I'm saying the right things, I'm just putting the wrong spots. So there we go. Just make sure. I did that on purpose to show you. No, just be careful where you're putting things. Okay, we're solving for pressure, right? So our equation is P1 V1 over T1 equals P2 V2 over T2. All right, now we want to get P1 by itself, so I'm just going to use my handy dandy little moving thing here. The T goes up top, the V goes down. All right, if you want to put a 1 in there so you don't have to change anything around, that looks great. Okay, if you can do that in your head, do it in your head, it's fine. All right, we have to change our temperature. So we're going to add 273 to both of these and change our Celsius into Kelvin. So that's going to be an 8. Why don't I just get my calculator out? It's been a long day. 273 plus 45 equals 318. And I'm going to do the same down here. Well, it's going to be 308, right? And I think I'm ready. Okay, make sure everything's in the right place. So V1, let's start here on the top. P2, 2 atmospheres. I try to match them up so they match the paper. V2 is 34. T1 is 318. T2 is 308. And then V1 is 28. 28, there we go. Okay, and so I'm trying to match them up like a above-below thing so they're in the right spots. That way I can keep track of everything. It just makes it easier. Okay, let's plug this in. Okay, clear 2 times 34 times 318 divided by 308 divided by 28. I'm getting 2.5. And that is 2.5 atmospheres. How do I know it's atmospheres? Because my other label was atmospheres. Okay? Be consistent with your labels. Make sure your temperature's in Kelvin. And besides that, it should be pretty easy. I think there's 7 problems. I just did it in under 20 minutes, so this shouldn't take you very long. Hey, have a great... Where's it at? Have a great... weekend. All right. See ya. Bye.